Hello, future engineers, subscribers, viewers, and students. Here is another video on trigonometry, particularly on determining exact trigonometric function values of angles that are or angles with reference angles that are common, and these reference angles were already discussed in the preceding videos that I uploaded. And of course, calculators are not allowed in this situation. So this will help you train your brains so that you can imagine, think, visualize to improve your thinking and analytical skills in math. I hope that you will enjoy watching and you will learn from this video. So problem there, determine the exact value by using the concept of reference angles. Calculators are not allowed. So number 1, cosine 120 degrees, 2 sine 1080 degrees, 3 cosecant 210 degrees, 4 cosine of negative 90 degrees, and so on and so forth. So let's focus first on the angle 120 degrees and let's find the value of the cosine. So we have this plane and the axis as our guide. 120 degrees is in that direction, counterclockwise. So if that is 120 degrees, therefore the reference angle, we draw a triangle here, the reference angle is 60 degrees as shown. So cosine of 120 degrees is equal to, so this is the angle, that's the triangle as our guide. This is the reference angle 120 degrees, and therefore the measure of this angle is 60 degrees. Parts of this triangle with 60-degree angle, I hope that you already studied and viewed my preceding videos on reference angles, particularly angles, quadrantal angles, angles such as 60 degrees, 30 degrees, 45 degrees, 0 degree, 90 degrees, and so on and so forth. So parts of this triangle, right triangle, opposite is square root of 3, adjacent side is 1, and the hypotenuse is 2. The adjacent side, since this lies on the second quadrant, is negative, you know that. So therefore this is negative 1. This is positive square root of 3, and that is hypotenuse 2. Cosine of 120 degrees therefore is like, because it is negative 1 over 2, it's like negative of cosine positive 60. And therefore it is negative, and cosine of 60 of course is 1/2. So, but if you base it from the figure, cosine of 60 degrees or cosine of 120 degrees is equal to adjacent negative 1 over hypotenuse 2. So it is negative 1/2. Then we proceed to evaluate sine of 1080 degrees. So in counterclockwise direction, because the angle is 1080 degrees, 1080 degrees is actually 3 times 360 degrees, 360, 720 degrees plus 360 is 1080 degrees. Take note, I'm not using the calculator. You should also think so that you will train your brains to improve yourselves so that you can succeed and excel in engineering. So therefore, it's 3 rounds, 3 revolutions, and it falls on the positive x-axis. The reference angle is 0, and we know that sine of 0 is 0. So sine of 1080 degrees is like sine of 0 degree, and therefore it is 0. Next is cosecant of 210 degrees. 210 degrees is, this is 180 plus 30, 210 degrees. So the reference angle is 30 degrees. We form a triangle here with reference angle 30 degrees, and we learned that it's like this is 30 degrees, the parts opposite to 30 is 1, but this triangle, this terminal side of 210 degrees falls in the third quadrant where both x and y are negative, so y is negative, negative 1, negative square root of 3, hypotenuse 2. So that's negative 1. So since cosecant of 210 degrees is hypotenuse over opposite of the reference angle 30 degrees, so cosecant of 210 degrees is like cosecant, negative cosecant of 30 degrees. But if we base it from this triangle, it is already 2 over negative 1, which is negative 2. But you can also make it negative of cosecant of 30 degrees, and it is negative of 2, negative positive 2 or negative 2. If I were you, just base it from the terminal side of the angle and assign the proper signs, which is hypotenuse, of course, is always positive 2, and the opposite is negative 1 because it is in the third quadrant, so negative 2. Next is cosine of negative 930 degrees. So we have 2 revolutions first, negative 360, negative 360, negative 720. Negative 720 minus 90 is negative 810. Negative 810 minus 90 is negative 900. Then 30 more, negative 930. So it's like a triangle here with this angle 30 degrees, the reference angle. So let's draw that. So that's the triangle, that's the terminal side for the angle negative 930 degrees. So this angle, the reference angle, is 30 degrees. So parts of the 30-degree triangle, same as this. Hypotenuse 2, adjacent, square root of 3, but it lies in the second quadrant, so negative square root of 3, and this is positive 1. That's 30 degrees. So therefore, cosine of negative 30 degrees is adjacent, negative square root of 3 over 1, over 2 rather, hypotenuse, so negative square root of 3 over 2. So it's like negative cosine of positive 30. But we base it from this original. This is our guide. Cosine function is adjacent over hypotenuse. Adjacent is negative square root of 3. The reason is it is in the second quadrant where x is negative and hypotenuse is 2. So it is negative square root of 3 over 2. 5 sine of 810 degrees. So 810 degrees, the angle reference to counterclockwise revolution is already 720 plus 90, 810, then 60 degrees more. So it's like this is the same terminal side of 870 degrees. But since sine is opposite over hypotenuse, opposite is 1 because it is in the second quadrant. Hypotenuse is 2, so it is like sine of positive 30, so it is 1/2. So it's 1/2. So later on, you are not obliged to this equivalent way, but you just make the triangle, put it in the quadrant where it belongs, then you can analyze the values of the exact values of the function. 6 is secant of 300 degrees. 300 degrees, 180, 270, then 30 degrees more, so that's 300 degrees. Therefore, the reference angle is 60 degrees. So let's have that triangle. So this is the terminal side of positive 300 degrees, the reference angle is 60 degrees. Opposite of 60 degrees is square root of 3, but since it is in the fourth quadrant, it is negative square root of 3. Adjacent side is 1, hypotenuse is 2. So secant of 300 degrees, I don't consider this anymore, but it's also similar to that, is hypotenuse over adjacent. So it is 2 over 1, so it is positive 2. It is also secant of negative 60 if the angle is measured in clockwise direction. So it is positive 2. 7 is sine of 150 degrees plus cosine of negative 420 degrees. For 150 degrees, this is 150 degrees. The reference angle is 30 degrees. So these are the parts. The sides and hypotenuse of the triangle are already there. So let's have the other one. Cosine of negative 420 degrees. So this is for 150 degrees. For negative 420 degrees clockwise, so that's 360 degrees, then negative 360 degrees, then minus 60 degrees is negative 420 degrees. So this is the terminal side of the negative 420 degrees. This is negative 240 degrees. I write here. So sorry, sine of 150 degrees is the reference. Sine is opposite over hypotenuse, so it is 1/2. So it's just like sine 30 degrees. Then it is cosine of supposedly negative 420 degrees. This is the reference for negative 420 degrees, and cosine of negative 420 degrees is adjacent over hypotenuse, so it is also 1/2. So it is sine of 150 degrees plus cosine of negative 420 degrees is 1/2, then plus 1/2, so it is 1. So next, number 8, tangent of 135 degrees, 135 is in counterclockwise direction, so the reference angle is 45 degrees. Let's have another figure. So this is the reference angle 45 because that's 135 degrees. So parts of 45 degrees, opposite is 1, adjacent is 1, the hypotenuse is square root of 2. The adjacent side is negative 1 because it lies in the second quadrant. Opposite is positive 1 because y, it is a positive unit, then this is always positive, it is square root of 2. So therefore tangent of 135 is opposite over adjacent, so 1 over negative 1. So it is negative 1. But it is also negative tangent of 45 where you are not obliged. You are not obliged. But we base on this figure, it is 1 over negative 1, so it is negative 1. Number 9, secant of 420 degrees. Positive 420 degrees is in counterclockwise direction. That's 360 degrees plus another 60 degrees. That makes it 420 degrees. So therefore the reference angle is 60 degrees. The terminal side of 420 degrees lies in the first quadrant and the reference angle is 60 degrees as shown. That's 60 degrees. Adjacent to 60 is 1, opposite square root of 3, hypotenuse is 2. Therefore secant, which is hypotenuse over adjacent, is 2 over 1, so it is 2. It is also secant of 60 degrees. Then 9, 10, cosine of 570 degrees. That's 360 plus 90, 410 plus 90, 540. So we add more 30 degrees. So it's like this triangle here. We already have a guide. This is negative square root of 3 because it is in the second quadrant. So cosine of 570 degrees is adjacent to this reference angle. This is the terminal side of 570 degrees. So it is adjacent negative square root of 3 over hypotenuse. So it's like negative cosine of 30 degrees, but you are not obliged to do that. You just base it on the figure. It is negative square root of 3 over 2. Then 11, tangent of negative 225 degrees. Negative 225 degrees is from in clockwise direction 180, then another 45. That's negative 225. Therefore, a triangle in the second quadrant, this is also the terminal side of negative 225 degrees. So this is our guide. And tangent of negative 225 is like negative tangent of 45, opposite over adjacent. So it is 1 over negative 1. Therefore, it is negative 1. So tangent of negative 225 degrees is like negative tangent of positive 45, but you just base it on the figure. Anyway, you can analyze it. Opposite over adjacent, 1 over negative 1, it is negative 1. Then sine of negative 60 degrees. So this is negative 60 degrees. This is our guide. That's 1, that's 2. This is square root of 3. But sine of negative 60 degrees is like opposite, which is negative square root of 3 because it is in the fourth quadrant, divided by hypotenuse 2. So it's like negative sine of 60, but you are not obliged to. You just base it from this triangle. It is negative square root of 3 over 2. You are not obliged to do that. You just base it directly from this reference angle and this triangle. Its position is important, location. So it is negative square root of 3 over 2. Then 13, cotangent of 240 degrees. 240 degrees is 180, then another 60 to 40 degrees. So it is like a triangle in the third quadrant with reference angle 60 degrees. Since we don't have a representative angle, let's have another figure. So this is it. 60 degrees. Parts of 60 degrees are opposite square root of 3, but it is in the third quadrant, so it is negative. Adjacent is negative 1, so 1 supposedly, but it is in the second quadrant between second and third, so negative 1, negative square root of 3, and cotangent is equal to adjacent over opposite, so negative 1 over negative square root of 3, so it is positive 1 over square root of 3 or square root of 3 over 3, and it's like cotangent of 60 degrees, positive 60 degrees anyway because it is positive. So it is originally negative 1 over negative square root of 3, which can be reduced to square root of 3 over 3. So it's like cotangent 60 degrees, but it is square root of 3 over 3. Then lastly, 14, secant of negative 300 degrees. Negative 300 degrees clockwise direction. That's negative 270 plus negative 30, so negative 300 degrees. This is the guide, but let's draw another one. to simplify, anyway, we still have space here. Then 2 tangent of 585 degrees. So let's have another drawing. Again, it's like this one, the terminal side of negative 360 degrees. So 1 square root of 3 because it is in the first quadrant, and this is 2, that's 60 degrees, the reference angle for negative 300 degrees. Then for 585 degrees, this is 360, 450 plus 90, 540, then another 45 degrees. So we have a triangle here with reference angle 45 degrees in the third quadrant. Parts of the 45 degree right triangle would be opposite one, adjacent one. But both these opposite and adjacents are all negative because the terminal side falls in the third quadrant. In the third quadrant, both x and y are negative. And the hypotenuse is square root of 2. So secant of negative 300 degrees is hypotenuse over adjacent. So it's like secant of positive 60 degrees, which is 2 over 1. While tangent of 585 is like tangent of 45 degrees because it is negative 1 over negative 1, opposite over adjacent, and negative 1 over negative 1 is positive. So it's like secant of 60 degrees, you are not obliged to do that, plus 2 tangent of 45 degrees. You are not also obliged to do that. We just base it from the figure secant of negative 300. This is the terminal side of negative 300 degrees. So it is 2 over 1, hypotenuse over adjacent, while tangent of 585 degrees is negative 1, opposite over adjacent, negative 1, so positive 1. So therefore, it is 2 plus 2 times 1 equals 4. So that's it for this video. I hope that you enjoyed watching, you learned something, and keep on watching, review this, try to do this by yourselves, try to imagine and find the reference angles, or try to create problems by your own, then check if your answers are correct using your calculator.